In Chapter 2, we will learn some fundamental two-dimensional joining skills. In the note today, we will go through the commands for the points and the different types of the line applied in two-dimensional joining. First, let's check the point command. To insert one point in AutoCAD, you can type the command point. Once the command is typed in the command window, you will be asked to define the location of that point. And this command will only allow you to insert one single point in the modeling space. If you want to insert more than one point, you have to go to the menu bar, select Draw, and go to Points, and then select multiple points to insert more than one point. Generally, the default type of the points is a dot with zero size. The type can be modified with different shapes and sizes. The command to modify the point type is a DDP type. Once you enter the type, the figure will pop out, and then you can select the type you want and define your own size for the points. In the next slides, I'm going to show you how to set the points in AutoCAD. Here, I will first show you how to insert a single point in the modeling space. To insert one point, you have to use the command point, and then you can identify the location of the point. Here you see that the point is a dot and it's very small, which is not easy for you to observe. And this would be the default setting of the point type. If you want to insert more than one point at the same time, then you can go to the menu bar, select Draw, go to Point, and choose multiple points. Then you are able to insert multiple points with one operation. Here you insert the 6 points on the screen, and once you want to exit this operation, press ESC. That's the way for you to insert a single and multiple points. And if you want to change the type of the points, you have to use the command DDP type. And then you have the point style window. Here you have 20 types of the points for you to select. You can choose any one of them by yourself. I'm choosing this one, and you also can modify the size of the point. The default value is 5%. You can change this one to 10%, and the size right now is relative to the screen. You can also set an absolute size for that point. So with this setting, you see that all the points defined in the modeling space will be modified by the setting you just defined. So that's the operations about the points in AutoCAD. The next thing we will learn is the line in AutoCAD. Actually, line would be the most common component in AutoCAD design. The command for the straight line is just the line. You can type the line in the command window to generate new line, or you can go to toolbar, select joining, and find out a line icon to generate a new line. For a new line, you have to first specify the origin, and then you have to define the second point, which would be the end of that line segment. You can use either the cursor or the coordinates in the command window to define the end of the points. If you don't exit that command, you will be asked to draw the second line, the third line, and until you finish all the design. And finally, if you want to close the last point to the first point of all the joinings, you have to type C to close the line. Remember, this kind of operation will only allow you to generate a set of separate line segments. They are not one single object, they are actually multiple objects. Next, I'm going to show you how to use the line command to complete the figure on the right. The figure in that example actually gives us all the coordinates for the 4 corners, and those coordinates are actually the absolute rectangular coordinates. So we can use the line command and those coordinates to complete the figure. And we will start from the left low corner, 50, and draw the figures clockwise. So first we will use the line command. And then you have to specify the first one. We have the absolute rectangular coordinate 5, 0, and then you get the first point. Next, the coordinate is 5, 5. And then you have to specify the third point is 10, 7. And then the first point, 10, 0. And now you complete all the 4 corners. You can use the option here, close, to connect the last point and the first point. And the command will help you to complete that line automatically. Type C. You will exit that command and draw last line to connect the first and the last point. That's the way for you to complete that figure with the line command. The second type of line we will learn is a construction line. Construction line is actually used as the reference line in the AutoCAD drawing a lot. With this command, you can draw a line with an infinite length, and the command to draw this line is the X line. You can also go to the toolbar, drawing, and select the construction line operation. Once you have this command, you will be asked to select a set of options such as the horizontal, vertical, angle, bisection, and offset. In the next slides, I'm going to show you how to use the construction line with all these options. Here I'm going to show you how to use the construction line to generate the reference lines. First, to operate the construction line, you can go to the toolbar, draw, and select the construction line. And you can specify one construction line with 2 points. That's the way for you to define a straight line. Select the first one and then the second one. Then you can define a new construction line. You also can specify the third point to generate the second construction line. If you don't want to generate more construction line, you can press enter to exit the operation. And we have several options for the construction line. So the first option is a horizontal. Type X line to activate the construction line. And once you select the horizontal, then you can only generate a horizontal construction line. You just need to specify one point to identify construction line. The second option is a vertical. Use the X line and choose vertical. Then you can only generate vertical reference lines. And the third one is the angle. With that one, you can actually specify the angle of the construction line respect to the positive x-axis. Now I'm set the angle as 45 degree. Then you can only generate the infinite long lines with the angle of 45 degree. And the third option is called a bisection. With that one, you can actually divide an angle evenly. So choose that one. Then you need to specify one angle on the screen. Here I want to divide this angle. Then you have to specify this one as the endpoint of the angle and choose the direction of the second line. And now this construction line actually divides the angle here evenly. That's the function of bisection. The last one is offset. With that one, you can define a construction line parallel to a line segment with certain distance, and the distance is defined as the offset distance here. Now if I specify the distance as 2 units, then you can specify the line segment and then define the site for you to place the reference line. And this one completes the definition of the offset with respect to this line. You can also define a reference line to this sloping line. So that's the way about the operation of construction line. The third type of the line we will learn in AutoCAD is called a polyline. You can use the command pline to generate a new polyline, or you can go to the toolbar, draw, and select the icon polyline to generate a new polyline. Basically, polyline is a single object that is composed of a set of line and arc segments. It will generate a single object. It's different from the line command, which will generate multiple independent line commands. In addition, we can modify the polyline. Use the command pedit or pe. There are several options under this command. You can choose close join with edit, vertex, fit, spline, and all the other options to modify the polyline. In the next slide, I'm going to show you how to generate the polyline and how to change the settings of the polyline. Here I'm going to show you how to generate a polyline. So you can either use the icon here in the toolbar or type the command pline to generate a new polyline. For this command, you should first define the start point of the polyline, and then the default segment would be the straight line segment. It will be similar to the line command. You can specify the endpoints of the line segments, and also you can close the last and the first point by choosing the close option here. And actually, polyline will be different from the line command. For the line command, if we draw a line command with multiple segments, and you will find that you cannot select all the segments at the same time, which means these 5 segments are independent to each other. But for the polyline, you can click at any location of the polyline to choose the whole 5 segments. And that means the polyline will generate a single object. So that's the difference between the polyline and the line command. Then next, I'm going to show you how to set a different segments for the polyline. So still, we start with the line segment, and here you see that we can also define the arc. If we want to define the second segment as the arc, you can click arc here. You actually have 3 methods to define a new arc. You can specify the angle. For example, you can identify the angle as 180 degrees. Then you will always generate a half and a half circle here. You can also specify the center of the arc and then define the endpoint to identify a new arc. And the third method is called the 3 points. You can use the 3 points, including the previous point here, to define the arc. Choose second point and then third point for you to complete the arc. And if you don't want to generate the arc anymore, you have to switch it back to line segments and generate new line segments. And here we have 2 options for you to specify the width of the segments. The first one is called a half width, which will only need for you to identify the half value of the width. The second one is the width. You need to specify the total width of the line segment. These 2 options will be quite similar to each other. If we want to modify the line width, first choose the half width, specify the start half width. We set that one is 0, and then you need to specify the end half width. I said that one is 1 unit. And then you generate a line segment with the start width 0 and the end width is actually 2, because here we define the half width as 1 unit. And similarly, you can use the width to modify the line width. Right now, you see that the line width is 2 units, and we keep that value. You can specify the end width as 0.5, so we'll make the width smaller. And now you see that it will generate a new line segments with a start width of 2, end width of 0.5. And let's modify this one back to 0. And let's go to see the last option called the length. If you choose the length, you can extend the previous line segments. For example, if I want to extend the previous line segments for 5 units, just type the value 5, and the line segments will be extended for 5 units. And also you can extend another length 6, they will be extended. And the last one is called the undo. If we choose this one, it will cancel your previous operation. And if we want to exit the polyline operation, press ESC to exit that operation. And that's the basic operations for the polyline. Next, I'm going to show you how to modify the polyline. To edit the polyline, you have to use the command pedit or pe. So here I'm using pedit. The first thing you need to do is choose the polyline you want to modify. Here we already have one polyline in the design, and then you have several options. The first one is called a close. If the first and last points are not closed by the polyline, then you can close them. And that's the function of close. If you don't want to close these 2 points, you can choose the option to break them. That's the first function, and then I'm going to introduce the other 3 useful functions under the pedit. The first one is the width. You can actually modify the width of the polyline. Here you can specify the width for all the line segments. I'm choosing that one as the 1 for all the line segments. Now the width of the line segments are modified. If we don't want to do that operation, choose undo to cancel that operation. And the next one is called the edit vertex. With this one, you can actually change the location of the corners defined in the polyline. So if we don't want the first point, you can choose the next point or the third point, or you can move back to the previous point. Use next and the previous to change the location you want to modify. And then here I'm just want you to understand how to use the move function. You can actually modify the location of that point. With the new location, the polyline will be modified. And that's the edit vertex option. And the third one is called the fit. With this one, it will use a smooth curve to cross all these corners. If we choose fit, the polyline will be smoothed. If we don't want to do this operation, choose decurve, it will change it back to straight lines. And the spline is another function for you to smooth the polyline. If we choose a spline, the polyline will be further smoothed, and this function will also be introduced in the next slides. And you also can change it back with the decurve function, and this would be the operation about editing a polyline. If you want to generate a smooth curve in AutoCAD, you can use the command spline. As we mentioned earlier, we can actually convert a polyline into a smooth curve with the option spline. Here, with the command of spline, we are able to create a smooth curve that will pass through or near a set of feed points, or that is defined by the vertices in the control frame. With the smooth curve, we can also do some editing. You have to use the command spline edit to added one smooth curve. Here we also have some options: close, join, fit, edit vertex, convert to polyline, reverse. And in the next slides, I'm going to show you how to generate and edit the smooth curve. If you want to generate a smooth curve in AutoCAD, you can use the command Spline. As we mentioned earlier, we can actually convert a polyline into a smooth curve with the option Spline. Here, with the command of Spline, we are able to create a smooth curve that will pass through or near a set of feed points, or that is defined by the vertices in the control frame. With this smooth curve, we can also do some editing. You have to use the command spline edit to edit one smooth curve. Here we also have some options: close, join, fit, edit vertex, convert to polyline, reverse. And in the next slides, I'm going to show you how to generate and edit the smooth curve. The last type of the line we will learn here is called parallel lines. This type of operation can help us to generate two or more lines which are parallel to each other. The parallel lines are actually very helpful for the design of the room layouts. In this example, you can find that the wall of the room can be represented by two parallel lines. In AutoCAD, the command to generate the parallel line is mlines. Actually, before you develop a new parallel line, you have to customize the style of the parallel lines. The command to define the style of the parallel line is mlline. With this command, you can modify the type of the lines for the parallel line and also the fill colors. Moreover, if we have two parallel lines which are crossing each other, you need to edit the type of the crossing part. In that sense, you have to call the command mledit to change the crossing style. In the next slides, I'm going to show you how to generate the parallel lines and how to set the style and edit the parallel lines. Here I will first show you how to generate a parallel line. To generate the parallel line, you have to use the command mline. And under the mline, you have multiple options. The first one is justification, which represents what kind of locations you will use for your cursor to identify the parallel lines. There are three different types: top, zero, and bottom, which represents the top line, the middle location of the two lines, and also the bottom line. So let's first choose the top, and then let's go to see how you will draw a parallel line. You see that your cursor actually defines the location of the top line. For zero, you are using the location between the top and the bottom to define new parallel line. That's the middle point between these two lines. For bottom, you will actually use the bottom line to identify the location of the parallel line. So here, this is where you place your cursor to identify the parallel line. So that's the first one about the justification. And the second one is the scale. This one actually defines the distance between these two parallel lines. Now the value is 1 unit. We can specify this one to 2 units. And then you will see that the new parallel line will have a larger spacing between the two lines. That would be the first two options. And the last one is the style. To modify the style, we have to first go to the definition of the style. So to define the style of the parallel line, you have to go to the command ml style. And then you will have this type of window pop out. Now you can define your own style. Click new here and specify the style name. I'm using the new ML style. And then click continue. Now you can specify the caps for the start and end, which represents the way for you to connect the 2 points at the parallel lines. You can use the lines which will be directly use a straight line to connect these 2 points, or you can use the outer arc which represent the arc to outside, or the inner arc, the arc go inside. And you also can specify the angles for the arc. So here we are using outer arc for both start and end. And also you can specify the color field between these 2 lines. Now for the field color, you can specify this one to yellow, and then you can specify the property of the 2 parallel lines, including their color and the line type, and you also can add one more line between these 2 parallel lines, and we can specify this property. For example, if we make the color of these 2 lines as red, you can choose the color as red for both lines. And for the line in between, we choose green. And then you also can modify the types of the lines. Now let's close the setting of the style and click OK. Then let's go to generate a new parallel line. Use the M line. And here you have to specify the style based on the name of the style. If we don't know the name, click question mark, and then it will show you the names. You have standard and a new ML style. Let's use the new ML style. And then you can generate a new parallel line based on the style just defined. Click enter, and that will be the line just defined. You have an outer arc to connect the start and the ends of the parallel line. You have the red top and the red bottom and the green in the middle, and also have the yellow field color. So that's the definition of the style for parallel lines. And also, if you have multiple parallel lines, for example, let me draw 2 standard parallel lines, and they are crossing with each other. You will see that the lines at this intersection cannot be neglected. In that sense, you need to call the command mledit to change the style at this condition. This one can help you to modify the intersections for the actually typical crossing intersections, and T-intersections also could be used for the corner joint or the card singles, all those things. Here, I just want you to know how to modify the crossing intersections. If we choose this kind of style, then only one directions will be fully displayed on the screen, and the other one will be covered by the one on the top. So if I'm choosing this one, you can click this one and this one to decide which one will be displayed on the top, which one will be hidden by the top one. And that's the way for you to identify the style for the intersections. You can also try the other styles by yourself. This is about the operation of the parallel lines. That's all about the first note of the fundamental two-dimensional joinings, including the setting of the points and the basic 2D lines. In the next slides, we will introduce some fundamental 2D objects.